Hey guys, working down in this area, just about got it done. Things are really opening up now, making sense. I can kind of breathe a little bit easier. So there were a bunch of extra components down in here. There were things that have been relocated, some extra power resistors, some stuff that I guess was tacked in there to try to fix some unknown problem. That's all gone. This is really all it should be down here, just these few parts. And even this is that latter addition that I'm still thinking about relocating, in which case there'd be hardly anything down here. Alright, then working our way up here to that drive control. I got all my C0G caps in place and the one mica for the 50 picofarad way down in there. So, that left really this, which was the 3-section electrolytic, where they had tacked in a rather ugly terminal strip. I was trying to figure out, can I relocate those somewhere? Can I do something about that? So, turns out one of them I put right over here. And this is actually a bit overkill. It only needs to be about a 250 volt cap, but this came with the set. I don't have any smaller 47 microfarad on hand. All the ones I got are 450, so that's what I went with. That I still need to reroute a couple wires, because they had actually cut a wire as near as I can tell and tacked it in over here, whereas it originally went all the way over in here. So I need to do that. This is a filter cap, I think, on one of the controls. I may or may not leave it there, but it's in a pretty good spot where it is, which left the last one, that one they definitely had on that new terminal strip. Well, eventually I sorted all that out, pulled it out of there. So it comes down to there's not a whole lot going to that point. It's 270K resistor going off the horizontal oscillator tube to the coil, and then there's a wire that I just put in. It goes up to pin 6 on the AGC tube. Originally these both went down to the filter cap here, and the only other thing going to that is this 22K resistor. So I got my new resistor going here. I added a wire going up to that tube. I'll put in a 22K resistor with longer leads over to that point. So I need to put a filter cap somewhere. Originally it was a 20 microfarad. I'll use a 22. This is the one that I had put in the set. I suppose I'll reuse it. So where can I put it? Well, let's look where that wire goes on this tube. There are two grounding lugs right next to it. One of them was never even used, so I can use that for the negative lead in the cap, put the positive there, and that takes care of that. Right next to it is that final little bit I need to clean up. This pin 7 on this goes to that lower B+, which goes over to this cap. So I need to run a wire from the connector up to that lug, and actually I think it already goes over to that. It's a little convoluted, but this goes down to there, which has a wire that runs over to here. So actually that's already done. Which brings up my last little point in this segment is I've worked on a number of Admirals with very similar chassis. I don't remember them being quite this convoluted. Now, just very brief history about Admiral, as best as I know it. Pre-war, they were pretty small. You don't see many pre-war Admiral radios, but they were around. Especially their wooden console radios don't turn up very often. Post-war, they were huge. I believe around 1950-51, they may have been the #1 TV producer in the United States. Which is a double-edged sword. I'm sure they were making some money, making a lot of sets, but they were also going through a lot of production changes, really cranking these sets out. They had part shortages. You see sets, especially in the early 50s, with parts from West Germany, from Japan. They were having to be a little creative with some of the substitutions. So sometimes you'll see a resistor doubled up in series or parallel, and that was done at the factory because they didn't have the right part they needed. But also with the production runs, I've seen there's one chassis I think may have 22 production runs because they made so many tweaks to it. So I think that's what some of this is because this is a somewhat later production run when they, like, this resistor is I believe a factory mod or it's done shortly after the set was made by a service tech, and that's why it's so convoluted with the wires running. And the same goes for some of these others. To give you another example, boy, it's kind of hard to see, but there is, I think it's a 68K resistor going off the horizontal oscillator down to a pin on the horizontal output tube. I think it's pin 6, something like that. Then there's a wire going off of it all the way to the front, the horizontal hold control. Let's take a look. That is this. There's no connection going from this to the horizontal output tube, but that's where it's connected. Turns out that pin isn't connected to anything inside of this tube. They're using it as a tie point. So there's a wire running all the way from here, all the way snaking down to that tube pin, and then they tack the resistor going over to where its final destination needs to be. They probably could have just used the terminal strip here with an extra lug or two on it, gone from the control right to the resistor, and then run a wire right where it needs to go. I've seen a number of things like that in this set, which makes it quite confusing because you kind of assume if you see a part and a wire going to a tube pin that it would be going to some element on that tube. But no, they use some of those as tie points, especially odd since there were 3 or 4 unused lugs on this terminal strip. And I said I've worked on similar chassis that didn't seem quite as messy. Maybe they were like I did do another 20B1, but it was clearly an earlier production run, and I looked at the reference, it was a fair bit different. Some of these parts were definitely located in other places. The terminal strip layout was a little bit different, so there's definitely a rapid evolution of this. That being said, generally these sets work well and they're very reliable. It's just a little annoying. One last thing that also drives me nuts working on this. Check out these wires. What do you see a lot of? 3 colors: yellow, orange, and red. And a little bit of white here and there, but you see an awful lot of orange and red and yellow. They use the same color wire over and over for totally unrelated things. That's really annoying, especially after having worked on a few predictors where they were pretty consistent, like B+ was always red. Would have been nice if they had done that here. I don't know if they had a shortage of wire colors or what. So some of these, like this blue, this is actually a new wire that I had put in here. Yeah, I don't know, maybe they didn't have any purples or whatever, or striped wire, but that, or green. I'm pretty sure there's not a single green wire in this set. So when you're tracing out these wires and you see 3 red wires right on top of each other and 2 orange wires and none of them are going to the same thing, it will drive you crazy. But I'm getting there. I'm almost done, I hope. Yeah, that worked out pretty well. I removed the cap that had been down here. There's nothing wrong with it, really, just the leads are really short. Yeah, that worked out pretty well, I think. I unmounted the cap that they had put in down here just because the leads are so short. There's nothing really wrong with it. It was just hard to see what was underneath it, which turned out to be a 47K resistor that I ended up replacing. Here's a new 22 with a long lead. Everything tying up into this point. Wire goes up here, and there is that filter cap going to the chassis grounding lug right next to it. And this filter cap is on the height control, which is back here. And then there's the third one, so the 3-section cap there. 1, 2, 3. That's it for the electrolytics. They have all been replaced and double-checked. Just about, or maybe I am done with the horizontal oscillator. Just a little bit to do up in here, which, let's see, that's the video amp, and that's AGC And I think, what is that? Maybe the video detector. So this is the stuff I'm talking about. And I think that's it. Finally. I finally worked my way up into the final corner. Up here we've got the video amp. It's the final stage before it goes to the picture tube. And then the sound IF and ratio detector. And I noticed something right away. They haven't done anything up in here. Not a single thing, including replacing the last electrolytic. There's a 4 microfarad on the ratio detector circuit. And this is a little unusual in that it's actually mounted on top of the chassis, even though it's a pretty small cap. It is this one right here. Usually, because they're only like 25, maybe 50 volts, 4 microfarad, usually they're paper wrapped electrolytics mounted under the chassis, but this one's mounted to the chassis, grounded to it, and they just left it in. And there's also an original mica cap going to it. So, one, I want to replace it, and two, it'll give us a chance to finally test one of the original micas to see if they're any good or not. Something else I wanted to show you is how one of these old resistors tests. That's a pretty common topic of discussion online is, what do you do about resistors? General agreement that you replace the old paper caps, you replace the old electrolytics. What about resistors? I've thrown out a few thoughts at times about my thinking. So like with the Predict is, it's a pain to take out the circuit boards. Once you got them out, just replace everything. Really old stuff like dog bone resistors from the 30s almost always drifted way off value, so replace them. Getting stuff in the 40s and 50s, it gets a little trickier. Typically, I replace the power resistors, especially the 2 watts and higher. Why? One, they tend to be huge, often drifted off value, especially the lower valued ones, and they're generally in pretty critical circuits, so I like to replace those. Especially like on a cathode bias resistor and an audio output tube, they're usually in the range of like 100 ohms to 300 ohms. They're very often drifted high, which is going to reduce the gain of that stage. What's not clear, or I don't have a really good plan often, is the values of the half watters in the range of like 1K to 1 meg. Usually the ones below 100 ohms rather are drifted way off, and the ones above 1 meg, I just check them, and if they're off I replace them. Otherwise I kind of leave them because sometimes they're kind of oddball values. It's hard to get modern replacements. The ones in between sometimes. So I'll just test a few of these and show you what I'm talking about. See if I can get this all on camera here. So we've got a 1 watt carbon comp resistor here, 3.3K. Get my probe on it. It measures 3.32. That's almost perfect. So I'd be inclined to leave that in circuit. However, here is a 68 ohm half watt on the video output tube. Pretty critical component, the critical point in the set. And it measures 148. It's more than double what it's supposed to be. So what I can tell you is I've worked on enough of these. Generally, TVs from 48, 49, 50, the resistor values less than 100 ohms have drifted way off. I'm not surprised to see it be 2-3 times what it's supposed to be. Replace those. kind of just even replace them without testing them. The ones in between, like I said, kind of depends. So here's a 27K resistor, and it measures 26.5. I'd be inclined to leave that alone. Here's one that's supposed to be 15K, 15.75, and another 15K, 15.39. And down below we got a 4.7 megger still in here, and it measures 5.2. I'd also be inclined to leave that alone. Another school of thought is that the more you tinker with it, the more parts you cut out and tug and pry and heat up lugs, especially like on tube sockets, you increase the risk of damaging them. J-hooks definitely reduce the chance because you're not stressing that out, but then it kind of can lead to a large solder joint, especially in a terminal strip where you want to kind of maintain some distance between the leads. So I generally clip the component off, leave some of the component leads sticking out, heat up the joint, and unwrap the old lead before wrapping a new one on. All that stresses stuff, so it's something to keep in mind. And yeah, component costs, but resistors, come on, 5-10 cents a piece, so I'm not too concerned about that. I know it's been hard to see because of the way these Admiral chassis are. They're deep, and I got overhead lighting, so it's always been in shadow, so I'm going to crouch down here and get my phone flashlight out and give you a better look at it. So those are the bottoms of the two cans that I opened up and replaced the mica caps on. Now notice there's another Candome power resistor hiding up there, and a big old 2-watter. So that's the kind of thing I like to replace. So that giant resistor on the left, that's 2 watts. A modern 2-watt resistor is like that. That is a 2-watt resistor. Believe it or not. It is like 1/10 the size. Why does that matter? Who cares? It opens up the chassis. It makes it easier to work on, easier to see what's going on, increases airflow for what that's worth. And arguably more reliable. Well, I don't think you have to argue it. They are more reliable. Especially if you go the respectable name brand, higher quality parts. But anyways, there's the rest of the sound. You see it's all ceramic caps, so I'm not going to mess with those. I will check the carbon comp resistors. I should replace the Candome. I tested it. It tests good. I think it'll leave it alone to test the set and power it up. It's a 6K resistor, a little bit of an oddball value. But for now, I'll leave it. Another one I really want to check is that big guy up there. That's supposed to be 4.7 ohms. So that's a really low value. Let's see how far it's drifted off. At first it measured only 2 ohms, which is unusual because carbon comp resistors, by nature of the material used, tend to go up in value with age, not down. So I took a look on the schematic to see where it's being used, and a little surprised. It is used in series with the filament supply. And then go to ground. So because this is going to all the other tube filaments and such, I figured it'd be a good idea to pop the tube out to completely isolate this resistor, and I did. And it jumped up to 5 ohms, which isn't terrible. I think I could leave it in there and it'd work all right. But that aside, why is it there? All these tubes run on 6.3 volts. They're all wired in parallel, except that one. Why did they put a resistor in series with the filament? It's obviously going to reduce the current flow through it a little bit. I'll do a little research on that. I don't think I've encountered that before. I did a Google search on 6AL5 filament resistor and very quickly found an answer in a discussion forum on a website called foundcollection.com. Well, basically it's to reduce the operation of the tube, to reduce noise, reduce contact potential, prolong its life. When it's used as a detector, it does not need to work very hard, so running it a little bit cooler apparently is a good thing. So there's the answer. And reading through the discussion thread, there's definitely some old hams on here, and apparently it was done in old national radios and Hallicrafters and so on, like shortwave ham type receivers. So here's a list of models that did a similar thing with those detector tubes. Interesting, I'd never encountered this before. I replaced that bad 68 ohm resistor and installed a new cap here. The original was a 0.004. They had put in a 0.0056. I went with a 0.0047, so it's closer to the original value. Still haven't replaced some of the stuff up here, but I think this is more than good enough to do a power-up test. But before I do that, I want to do something about the power cord. I cut out the one that they had jammed in here, and these are the two leads that are left. I want to install a new AC interlock connector to replace the one they had hacked up. You can kind of see it down there. It's riveted. Unfortunately, the rivets are on they're crimped over on the back side, because the easiest way to get those out is to drill them out from the crimped side, which I won't be able to get to, so I'm going to have to somehow do it from this side. Here's a better look at it, and luckily the replacement is identical. The same dimensions fit right into those holes, so it would look like that. So what I tried doing is taking a really sharp drill bit and get right in the center there and see if I can drill those out. Otherwise, yeah, I suppose I could get something slim, sharp like a chisel, and kind of get it in there and try to pop them out from this side, but I'll go with the drill first, see where that gets me. Piece of cake. Drilled out the rivet heads, popped it out, and there we go. I'll get some small screws, lock washers and nuts, and secure that and wire it in. And while doing so, I'm glad I did this, because that reminded me I still have to repair that broken cap lead and dig up a missing screw for this. And once I got this in place, the back cover will sit on all the way deep like it should. So I will also dig up replacements for these screws and the one down there. And there we go. Brilliant. Worked out perfectly. And to secure it, I use the closest thing you can pretty much get to rivets without using rivets, which is button cap screws. Great suggestion I got from one of my viewers years ago when I was replacing some tube sockets that had been riveted, was to get these guys. 440 size, 3/8 inch long threads. Got a set of 100 screws, lock washers, and nuts. Use them all the time. Especially important on this because the back cover fits onto it and it's recessed, but not a whole lot. So if you were to use, say something like sheet metal screws like that, they'd probably stick out a little too much and this cover wouldn't go on all the way. This will look real nice, I think. So this should now slide on all the way. Yep. So that is making complete contact, fully seated, and there is a screw that you can drive in there. It not only holds the back on, but it keeps the power cord in. So that'll be the next challenge, to mount a power cord on this. This is what I'm talking about. This is what was on here originally. And there would have been some nice brass rivets going through there to hold it on. Without it, this could be made to work. There, it's on there pretty well. And then you have that screw to secure it down, but yank card, of course, comes right out, so not ideal. Screws, this is nylon. If I tighten the screws down, this is just going to mush. So what other options do I have? Well, I do have some rivets, but they're way too short. I could get some longer rivets maybe and try to re-rivet it, or go through my stash. I parted out a number of Admirals, mostly the 30 series. Well, this is a 20 series, and I know I've got some spare back covers. If they're the right size, and if I've got any that have those brass rivets. I don't care if the power cord is shot, because you can heat this up and make these ears more pliable and slide them over the original rivets after you remove the remains of the original power cord. I've shown that in a few videos in the past. But one way or another I'll figure something out. But certainly I can power it up without doing all that. In fact, I'll probably be powering it up with this cover off so I can see what's going on inside here. But just replacing that interlock is a huge step in the right direction. Now I can go back underneath and clean up all that wiring and dress it neatly and make it safe and secure. And I think I'll add a fuse while I'm at it. So something curious, in some of the later Admirals, there were one, sometimes two fuses up here. Whereas this has a pigtail fuse underneath, which is I guess that was factory original, that's the way they did it. So that's just a 1/4 amp fuse, and it's only on the horizontal output circuit, basically to save the flyback if something goes bad. Later versions had a dual fuse holder, one to fuse the whole set, and then one for the flyback. So not a bad thing to add. So I suppose in keeping with the existing just tacked in pigtail fuse, I can stick another pigtail fuse underneath, and this is what I'm talking about. So, oh yeah, and thanks to a little detective work, so MDV is a type of slow blow fuse, and the one means it's a 1 amp fuse. So this is not the right type of fuse, it should be a 1/4 amp. And then I can add another similar pigtail fuse somewhere in the switch, blind circuit. To fuse the whole set. For that, 2 amps, 3 amps, something like that would be appropriate. Alrighty, got the power wired into the new connector down below, repaired the broken off high voltage anode lead, got the power supply up on the workbench, and now I know you guys are going to kill me, but I'm going to be breaking things off here before the first power up. Why? It's late, and I put a ton of work into this set, as have apparently 1 or 2 repair shops before me. I want to get this right. It's late, I'm tired, I want to clear off this whole workbench. And then I need to do a little bit of homework because I don't have anything plugged into that. That would go to the radio, which I have not restored yet. In fact, I keep forgetting about it. There's still a radio that needs to get restored. I think I need to short something out here to operate the TV on its own. I also need to figure out how to rig a speaker up to this mess. In fact, I should probably remove all these wires and wire something in here. These have been cut, they've been spliced, and they've been cut again. I think this might have gone to 2, well, there's 3 wires. So normally I'm used to sets having a single speaker, so I'm not sure what all is going on there. I know it's push-pull output. I don't know if it went to 2 speakers in parallel or in series or what's going on with that. Also got to hook up the sound output from the TV. We got this coax with an RCA connector over here that plugs in down below. And finally, we got to do something about this. This is, or was, the connector that goes to the phonograph motor. Pretty sure it's got 120 volts AC on it. No. No, we are not going to leave this like this. I will probably just cut it off somewhere inside. This is not safe. I'm not sure what the owner's intent is, if he ever wants to use the phonograph or not. If he does, I will certainly put new wire on this, put like a lamp cord, and see if somebody out there has, maybe one of you guys knows, what kind of connector this was. It's obviously a chunk of it gone. I think it had 2 connectors, probably a fairly standard thing for back in the day. Alright, so, sorry, bear with me. Next installment, you'll see hopefully a very clean workbench, and this all laid out and connected up properly with 1 or 2 test speakers, and we're going to give this a go.